All right, in this lesson 3-3, we will be looking at the slopes of lines, particularly the types of slopes of lines, how we can find them from a table and a set of ordered pairs, as well as counting on a graph. At the very end, we will also look at what do you do when you have the slope and parts of information, but not everything. This is a longer video and is actually broken up into two different lessons. So you will see me put in a pause. I want you to pause, stop, and then come back after you've done some practice to finish out the lesson. Okay, so some active vocabulary. When we are working with slope and what is known as rate of change, we are talking about the same thing. Both of them mean the same thing, but are different ways of finding the same number. So the rate of change is the change in the y values divided by the change in the x values. So we use subtraction or addition to figure out what is the difference between one y value to the next y value. What is the difference between one x value to the next x value? And we always write this with y on top, which is new from what you have been doing. You often will use x first. In this case, we are looking at the y values on top. This is the case when we are talking about slope. Slope is known as rise over run, and we use it when we are looking at the graph. If we have two ordered pairs on a graph, how many points do I need to go up or down, which is the rise? And then how many do I need to go left or right, which is the run, to get to the next point? And when we are working with ordered pairs, you will see that we have an equation. The y2, y1, x2, x1 refers to how we write our values and assign values within our ordered pairs. So if I had a set of ordered pairs, I would put one of them as x1, y1, and the other as x2, y2. And you'll see me go through and I'll show you how to label those throughout this video. But first, before we do that, we're going to talk about the rate of change. So and you'll see me abbreviate this as ROC. How do we determine the rate of change from a table? So we always want to start with the y values here on top of our fraction that we are going to be using. So in just a moment here, you'll see I am working with the number 156 and 78. So how do I get from 78 to 156? Or in this case, from 156 to 78. So how do I go from here to here? Or the other way around. And in this case, to go from 78 to 156, you can take your calculator out and do some subtraction. And you will see that they are adding the same value each time, and it's 78. So to go from 78 to 156, they are adding 78 each time. To go to 156 to 234, you can bet they're going to add 78 again. So once we figure out the difference to go from here to here, I'm also going to do that for my x values. I have a 2 to a 4. That's easy. That's plus 2. And the same thing happens when I go from 4 to 6, plus 2. So how do I write this? Well, I'm going to write this as my change in my y values, or in this case, plus 78 over plus 2. Now, because we're talking about rate of change and slope, we want to use 1 as a number on the bottom if we can. So in this case, 78 divided by 2 is going to give us a whole number, and that ends up being 39. 39 over 1. And this is okay. If you get you can leave it like this. You do not have to write 39 as a whole number, but you can. And the reason why I say that is because this 1 on the bottom is important here. What this means is that the total cost of the computer games, because this is the information in the table, is $39 per one game, for each game. So that's why the 1 is important. You can, of course, reduce it to 39, but you also need to understand that there is a 1 on the bottom, and it is going to be counted into how we explain what is happening in this table. You have a little on your own problem here that I want you to try. Pause the video and give this a whirl. I will write the answer in on the bottom and go through how I did it. Okay, so by now you have completed this problem. I am going to look at my change in my y's first. So 48 to 96, I am going to subtract here. And I find out that when I do that, I get 48. So each time to go from 48 to 96, I am adding 48. Okay, each time I go from 3 to 6, I am adding 3. So my rate of change is 48 over 3, which when I divide gives me a whole number, tells me that I am 16 over 1. I can divide 48 by 3 and 3 by 3, so I've simplified my fraction. So what does this mean? This means that the area of the tiled surface is 16 inches squared for each tile. Sometimes when you are working with these tables, they don't always have a constant rate of change. And so you can figure this out by looking at the changes in the y's and the changes in the x. And in this case, I'm going to start with my y's over here. I have a -6 to a -8. That's a -2. And if I keep going down each time, the difference is -2. Okay, so that so far is good. That's a good indicator. Now I'm going to look at the x's. My 1 to 4 is a +3. Each time I should be getting +3. This tells me that this function or table has a constant rate of change, which means that my line should be a nice and straight line like the one I just drew below it. This rate of change would be written as -2 over 3 because I am minusing 2 from the y's and then I'm adding 3 to the x's. You can also, like I said, sometimes they don't have a constant rate of change. And here's where we might start to notice that. That's when that fraction, the -2/3, would be different. So to go from 10 to 12, I'm going to add 2. From 12 to 16, I'm going to add 4. From 16 to 18, I'm going to add 2. And from 18 to 22, I'm going to add 4. Now, what we want to make sure is that our fractions reduce to the same amount. So in this case, if I go to -3 to -1, it's a +2. So my first fraction should be 2 over 2. But here's where it gets different, and this is how we know this does not have a constant rate of change because we go from -1 to +1. Which is still a +2, but our fraction becomes 4 over 2. Once you get to this point, you're going to notice that there is a pattern that emerges, but it's not one that's going to be a constant rate of change. Each of this piece here, we have a fraction of 1, a fraction of 2, a fraction of 1, a fraction of 2. So when those numbers are not the same, they do not have a constant rate of change. Okay, so how do we find slope, or in this case, rate of change, either one on a graph? So first thing we have to do is make points on the line. So I'm going to go over here to my graph and I'm going to pick a spot where I see that my line crosses through a whole ordered pair. And in fact, I'm going to put 3 points on my line and I'm going to highlight them so that you are able to see them. I'm going to highlight them in red real quick. Okay, so these are kind of big, just so you're able to see what I did here. And so we have put these points on the line. We're going to start from the bottom or the left. So the furthest left point, and we want to find the rise. The rise is how far up or down I need to go to get to my next point. So I'm going to start here at my point, and I'm going to count up 1. And to get to my next point, I'm already at that level. So my rise goes from here just up 1. So that makes my rise 1. The top of my equation is a 1. Then I'm going to find my run. So to find the run, you count over. How many do I need to count to the right or left to get to the next point? And in this case, I've gone up 1, and now I'm counting 1, 2 to the right. Notice how I didn't go start it the value of going up 1 and immediately start by counting 1 and go 1, 2, 3, because that's not right. It's actually only 1, 2 spaces over to the right. That is a common mistake I see. So in this case, your slope is 1/2, 1 over 2, because I went from here to go up 1 to the right 2 to get me to the next point. If you did this and you got a fraction that wasn't simplified, now is the time to do that at your very last part. Okay, so each graph doesn't have, there are 4 types of slope a graph can have. The first one on the top left here says as we travel left to right, the graph goes, it's going to be going up. So if I start on the left-hand side of my graph, my line is moving up and to the right. So in this case, this is a positive slope because it goes up and to the right. The opposite happens when, as we go left to right, the graph goes down. Notice how I'm talking about in terms of right. That's important here. This is a negative slope if it goes down and to the right. Okay. The graph is not steep at all. In fact, this is a 0 slope. I am not going up at all here. I can keep running forever and ever and ever, but I'm not going up. And this graph on the very last one is a vertical line. This is an undefined slope. And it is undefined because when we do our numbers with it, it will be written as like 3 over 0 because we are not moving left to right at all, but we might be going up 3 to put the next point. You cannot divide by 0. So this is why we call it undefined. Okay, so now that we know the different types of slopes and you know how to find them from a graph, we can also find them when we are working with just ordered pairs. So no picture, no table, no nothing. We have just 2 ordered pairs. So the first thing you need to do is use the formula to find the slope. And if you forgot the formula, you're going to have to remember this and commit it to memory. It is, it's not y equals, that is my mistake there. It is going to be m equals, m referring to the slope, y2 minus y1 divided by x2 minus x1. And so even as an older person who's been doing math for a very long time, I still label my points. I pick the first one and I make it x1, y1. And then I do x2, y2. It doesn't matter which one is x1, y1 and x2, y2, as long as you keep the 2's together and the 1's together. And I'll show you how you can reverse those in the next one. So, for instance, if I am doing this problem, I want to use my formula now, and I have my points, and I'm going to put them into the formula. So y2 is 5. y1 is 0. It's always going to be 5 minus 0 here on top. I don't have to change anything because both numbers are positive. The next one, my x values, 1 minus a negative 2. The default is minus, and because I have a negative, this turns into a minus, a negative, or plus, which gives us 3. So my fraction for my slope is 5/3, and I want you to leave it like that. I don't want you to turn it into 1 2/3. Just leave it as 5/3, 5/3, because that tells us that to go from point to point, I am going to go up 5 and to the right 3. Okay, in this next example, we have a -3 and 1, and 2 and -1, and I'm going to make these x2, y2. x1, y1. And you can see here that I flip-flopped where I put the 1s and where I put the 2s from the previous problem, and that's okay, as long as I keep my 2s together and my 1s together. I'm going to go through the same process. I'm going to substitute in my y's. -1 minus -1 divided by -3 minus 2. This is going to give me a fraction here. -1 minus a -1 turns into -1 plus 1 over -3 minus 2, which is 0 over -5. Whenever you get a 0 on top of your fraction, this is a 0 slope. In our previous problem, we had a positive slope because our number was positive. In this problem, when 0 is on top, our automatic answer is a 0 for the slope. Okay, so we have 2 more examples here. And remember that we are using our formula, y2 minus y1 over x2 minus x1. So here what we're going to do is label our points if we need to. So I'm going to go x2, y2, x1, y1. I'm going to put them into the formula. -2 minus 9 over -4 minus -4. That's going to leave a -2 minus 9 on top and a -4 plus 4 on the bottom, because the double negative minus a negative turns into a positive. This is going to give us -11 over 0. When 0 is on the bottom, it's undefined. So this is an undefined slope. And you would write either 11 over 0 or the word undefined. I'm going to underline it here for you. Okay, so those are the 2 options for you with that. Now, if you're paying attention here, we've had an undefined slope, a 0 slope, a positive slope, which might lead us to believe that the next one might be an example of a negative slope. So let's see and find out. I'm going to go through and do this problem. Okay, so here we will begin with x1, y1, x2, y2. So I have -3 minus 4, and I'm using the -3 from the right side, not the -3 that's on the other ordered pair. And then I'm going to do 2 minus -3 because that's my x2 minus x1, which is going to give me -7 over 5. If you had done this the other way around, you would likely have also gotten the same answer with the negative on the bottom. As long as there is only one negative, the whole thing is a negative slope. Okay, you're going to have a chance to do the on your own problems right now, and I want you to go ahead and give those a try. You can see that the answers are written here, and I will go over any questions that you might have in class. Okay, at this point you've had some time to do the on your own problems. I've given you the answers. I want you to pause the video here and try page 15 with questions 1 through 15. This would be a great point to stop once you've done that, and depending on where you are, the next part is a little bit trickier. So make sure that you really understand what's going on with these questions before you move forward. If you need extra practice, you can always go to the page before on page 14. Okay, so now that you've had some practice working with finding slope from 2 points, we are now going to do a little bit of an application. So sometimes you can find the slope of a line and you know one of the points, but you don't know everything. So we need to remember when we're working with this, if you haven't committed it to memory, the slope formula. M equals y2 minus y1 divided by x2 minus x1. And so how do we solve a problem where we find the value of r so that the line through the points has the given slope? So you are given 1, 4 and negative 5, r and a slope of 1/3. So what we're going to do is use our equation from above and we're going to put in what we know. I'm going to label my points here. x1, y1, x2, y2. And my slope is m. So here's what this would look like. 1/3 equals, because that's my slope, r minus 4 divided by negative 5 minus 1. So step 1, once we've plugged everything in, is to subtract. And what am I subtracting? That bottom half of the second fraction. R minus 4 stays the same. I'm going to simplify negative 5 minus 1, which is negative 6. So how do I solve this? Well, I go to solve this proportion by using cross products. So we're going to cross multiply. So I'm going to show you here with my red pen what we're cross multiplying. We are cross multiplying 1 and negative 6 and r minus 4, the quantity, times 3. So here's what this looks like. I want you to write out your cross products. 1 times negative 6 is negative 6. Then you've got 3 times r minus 4. That r minus 4, if there's a variable minus a number, you need to put that into parentheses. And in order to do this, next part, you have to distribute to solve. So negative 6 is going to stay the same. I'm going to distribute the 3 to the r and the 3 to the negative 4. 3r minus 12. And here I have a two-step equation. So I'm going to add 12 to both sides because my goal is to isolate the variable. That is going to give me 6 equals 3r. I divide both sides by 3 and I find out that the value that makes the slope true and fills in my points, my 2 points on my graph should be 1, 4 and negative 5 and r, which is 2. So you can check this on your graph. If you were to graph these 2 points, you would see that they have a slope of positive 1/3. And that is how you can go about checking your answer. Sometimes when you do this, you might have the r in a different position. The process is still the same. With the exception of step 2, you might have to add or subtract depending on what that simplifying step is. If you have, for example, a slope that does not have a fraction in it. So if our points were 2, 5, r, 7, for example, and we had a slope of 2, we would set the problem up just the same. We would say x1, y1, x2, y2, and our slope. So 2 equals 7 minus 5 over r minus 2. Okay, so I set this up, and I simplify my top part of my fraction. 2 equals 2 over r minus 2. So how do I solve this? Well, remember that whole numbers always have a 1 on the bottom. Okay, whole numbers always have a 1 on the bottom. So you are going to cross multiply. 2 times r minus 2. And then in this way, 2 times 1, or just 2. Okay, and you have a question that looks very similar to the one that we did before. You distribute, so 2r minus 4 equals 2, and you can solve. and you end up with r equaling 3 by the time that you are done. So if you have a whole number, you can put that invisible 1 on the bottom, and that will help make it whole.